All right, everyone, it's fraction action again. Here we go. I have loads of fraction comparison problems right here and a highlighter. Why? Because when you are looking at comparing numbers that are fractions, you need to get that fraction sense, your fraction goggles on, and look and be like, okay, what do I notice happening here? Yeah, I really need to take notice because if those denominators are the same, I'm going, yes. If those numerators are the same, I'm going, oh yeah, this is good, life's good. Okay, so that's what I'm going to be on the lookout first for. So I'm going to go ahead and say, yeah, this one, I'm going to highlight this because that I'm for surely doing this one right away. My numerators are the same. Okay, so I'm going to go ahead, highlight up. How about here? Do I have numerators the same? No. Denominators? No. Okay, I'll save that one for later. This one, everything's the same on that. That is awesome. Okay, am I going to be highlighting number 4? No. It doesn't mean that it's not that I'm not going to do it. It's just not going to be the first one that I do. This one, no. This one, number 6, am I going to highlight? Yes or no? No. How about number 7? Nope. Number 8? Hopefully you're saying out loud yes or no. Number 8? No. Number 9? No. Nope. Man. Okay, how about number 10? Nope. All right. Are there any that I'm going to highlight on the right side? Figure out in 5, 4, 3, 2, 1. Cha-ching! Oh, looks like I'm highlighting number 14. Numerators are the same. Okay, any others? Yeah, 15 right after it. Numerators and denominators are the same. And then I really don't see anything else except number 18, when the denominators are the same. So I have highlighted the ones that I would pick out of the crowd and do right away. So this one, both numerators and denominators were the same. Those are equal. 1/2 is the same as 1/2. Cha-ching. All right. I'm going to go over to this other one in that column, and the numerators were the same. So I had 1 of what? The fifths. Whereas here I had 1 of the thirds. So now I have to think the pieces. I'm thinking fifths, I'm thinking thirds. Which piece is going to be the bigger piece? So if I take my rectangle and I cut it up into 3 parts versus taking my rectangle and cutting it up into 5, which piece is going to be bigger? It's going to be the third. Thirds are going to be bigger. Even though 3 is smaller than 5, that's not what we're talking about. We're talking about thirds and fifths. So thirds are actually bigger, okay? When we take a look visually at it, they're bigger. All right, let's go over here. Another one where the numerators are the same. So now I have to think not a 3 compared to an 8, but I have to think thirds compared to eighths. Would I rather want a third of a cookie or an eighth of a cookie? Either way, whether you like cookies or not, I'd want more food. More. I'd want a third. Okay? More. Thirds are going to be bigger. Even though 3 is smaller than 8, we're talking thirds. Okay, this one, we have denominators the same and numerators the same. Okay, that means they're just the same. Equivalent. Okay, and number 18, this time, finally, our denominators are the same. So I have 1 of what? The fifths. Whereas here, I have 3 of the fifths. I have more of the fifths right here. I have 3 of them. So that is going to be more than just 1 of them. Okay? All right, so those are super awesome, super nice, and you want to be on the lookout for those types of fraction comparison problems because that's when you're like, oh yeah, things are going good. Now, there's a lot of problems left on here that we didn't highlight. So now I'm going to have you pick up your pencil, and you're going to circle we're going to be on the lookout for certain ones, okay? So go ahead and circle number 2. and say, there's something special happening here, okay? So, and this guy is like, oh, yes, I noticed something. We could do something here. Yeah, well, the denominators aren't the same. The numerators aren't the same. So what the heck are we going to do? Well, watch. Oh, who's going to come help us out? It's the superhero benchmarks of 0, half, and 1. And which one in particular? A half. Because look at 3/4. Well, I know 2/4 would be halfway. 3/4 would be more than a half. Whereas 4/8, well, oh my gosh, half of 8 is 4. So this fraction right here is exactly a half, whereas this one is more than a half. So then I'm able to say that 3/4 is more than 4/8 because it was more than a half. So now can I use this fraction sense using those benchmark numbers of 0, half, or 1 to help me with any of the other ones that I did not highlight. Go ahead and take a few minutes and see if you could use that half to help you like we just did in that particular problem. Go ahead, pause the video, try it out yourself, try to find at least 2 more, okay? But there are more than that, okay? All right, here I go. I'm gonna go ahead and start. So, boom. Oh my gosh, you guys, look at all the ones I ended up circling. Holy cow, there were a lot that you could use your fraction sense and the superhero of 0, half, and 1 to help you figure this out. Take a look at number 5. One of them is already worth a half, whereas this one is not half. But if I were to draw out 4/5, is that going to be more or less than a half? So here's 0 to 1, cut it up into fifths. 1, 2, 3, 4, 5. There's 5 parts. And halfway is going to be like right here. 4/5 is right here. 4 of the fifths. That's more than half. Here's more than half. So that guy's going to be more than the half. Cha-ching. Okay. What about here? Can I use my half to help me here? Well, I already know 4/5 is more than half. This number is not a half, but it's 1/4. So now when I'm talking fourths, is one of those fourths going to be half? No, that's less than half. So 1/4 was less, 4/5 was more than a half. So I'm able to say that 1/4 is less than 4/5 just by using my fraction sense of the amazing fraction of a half. That is awesome. Okay, let's try one more. Let's go over here to this one. Okay, so now I don't see either of these representing half, but I see one of them is less than a half and one of them is more than a half. Put an L and an M at each one of those fractions. Which one's less? Which one's more than a half? You got it? Okay, here I go. 1/3. When I draw that out and I go from 0 to 1 and I draw my thirds, there are my thirds, 1, 2, 3 parts. Here's my dotted line of halfway. 1/3 is a little less than half. So this guy's the L. 9/10, if I draw that out, oh my gosh, 9/10, that's like super close. That's 1/10 of the way to being at 1. That is very close to 1 whole. So I am then able to say 1/3 is less than 9/10 just by using my half idea. Okay? So those can really help you out when comparing fractions. But what about the ones that I didn't circle? Like there are some left over. What do we do with these ones if we can't use 0, half, or 1? Or that doesn't work out for us? Well, let's take a look at this one in particular. This one was number 6. Okay, number 6. Or was it? No, it was number 4. Sorry, number 4. 1/4 compared to 2/6. Did I have common denominators? No. Did I have common numerators? No. Can I use the benchmark of 0, a half, or 1? Well, if I go half, 1/4 is less than a half. 2/6, that's less than a half. Oh no, they're both less than half. They're both close to 0. What if I draw them out? 1/4 and 2/6, is that gonna be good? Okay, I could try. 0 and 1, make it into fourths, do my best at fourths, go to 1/4, and then say, okay, now I have to cut it into sixths from 0 to 1, cut it into 6. So now I go 1, 2, 3, 4, 5, 6, and then I go 2/6 of the way. Well, on my drawing, 2/6 looks like it's a little more, but man, that is close. And my drawing is not like super precise. So because they're so close, I don't know. So I'm gonna have to do something else. And that is called making your denominators the same, or common denominators. So I am going to have to look at 1/4 and what's the other fraction? 2/6. And I have to try to make those denominators the same. In order to make them the same, I'm going to have to look at what's called the multiples of 4 and the multiples of 6 and see when are their multiples the same? When are they common? So I'd go, okay, well, I have 4, add 4 more, I'm at 8, add 4 more, I'm at 12, add 4 more, I'm at 16. I could keep going and going, but I'm going to stop and try starting the 6's and see if I have a number that is the same or common. 6, add 6 more, I'm at 12. Add 6 more, oh, wait a second. I already have a number that is the same, common, and it's small. It's the least common. And so we call it the L, least, smallest, same, common, multiple. Least common multiple. I could keep going in my multiples and find one that's bigger, but why? You want to end up using the smaller one. It'll be a little easier. So now what do I do with it? Well, I need to take 4 and morph it into that 12. So how do I do that? Well, this is the 1, 2, 3, third multiple. So I'm going to take this fraction and I'm going to multiply it by 3/3 right here. And you guys, 3/3 is the same thing as 1 whole, 1. So really, I'm not changing the value of this fraction. I am just changing the way it looks. It's just putting on some different clothes. So 1/4 is putting on the clothing to become 12ths. So I'm going to say, how many 12ths is that worth? 3 of them. 3 12ths. So when I draw a picture of 1/4, and I cut a rectangle up into 4, and I have one of those parts, and then I take that same rectangle, but now I chop it into 12ths. Oh my gosh, that takes a lot out of me. Okay, 12ths, that's a lot. But I'm going to try it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I need 6 over here. But I only need 3 of them. 1, 2, 3. That should be the same chunk. This is the same amount. 1/4 is the same, equivalent to 3 12ths. But why do we do it? Because we can morph this one into 12ths also. And then it's really easy to compare. So what am I going to multiply this one by? Because I'm not going to multiply this one by 3/3. I'm going to multiply this one by, well, here's the first multiple, the second multiple. So to get that one to morph into 12, I'm going to multiply it by my 2/2. And now 2/6 is going to put on the clothes, the 12ths clothes, and it'll be worth 4 of them. So now I'm able to say, well, 1/4, you're the same as 3 12ths. And 2/6, you're the same as 4 12ths. So now I know, how could I compare 1/4 with 2/6? Now I know which one's bigger and which one's smaller. Do you? Okay, I can tell by looking up here. 2/6 was worth 4 of the 12ths. whereas 1/4 was only worth 3. So